Welcome to day 2 of paleontology. I hope that day 1 went well for all your classes, including mine, and I hope today goes well. Uh, we're going to start very, very broad in this class, and what I really want to take a look at here is this animal right here. This is Pakicetus. And so when you're looking at Pakicetus, he's a prehistoric animal that lived about 55 million years ago. Just after the death of the dinosaurs, he kind of came to be. He wasn't around when the dinosaurs were around. He kind of filled a niche. A niche is a word that we're going to use a lot in this class. Niche means a job. And so the way to think about a niche is kind of like in your community, there's a certain amount of jobs. Not everybody in Kalkaska could be a doctor. If everyone was a doctor, there'd be not enough patients for all of us, and we wouldn't be able to make it. Kind of like not every animal could be a Tyrannosaurus Rex or a lion or a tiger because there wouldn't be enough food. And so there are niches that every animal fills, and this is due to evolution, and animals try to fill these niches and jobs the best that they can. And that's how we've all evolved, is to fit our job in the ecosystem. This is Pakicetus, like I said. As you can see, he's about 5 feet long, about the height of a dog. What's interesting about Pakicetus is you guys are all familiar with his common day today relative, or what he actually eventually turned into. And looking at him now, you wouldn't really see what he's about to turn into in the next 55 million years, but that's the journey we're going to have to take. We're going to have to start looking at animals a little bit differently and how they fill into their niches and how that kind of shapes who they are. So taking a look at him right now, I want you to take a moment and see if you can see any familiar traits. So he's got a really, really long face. His body is kind of longer. He's got a tail, like most mammals. He's got some interesting looking feet. He doesn't really have the right amount of fingers on there for what we're used to, I guess. He's only got 4. You kind of see, like I said, he kind of looks like a dog. So this animal used to live on beaches in North America. We'll talk about where North America was at that point, but he lived on the beaches and he would eat fish. He was actually a fish eater, and he'd swim out into the shallows and try to get as much fish as he could. Over time, the better swimmers could get more fish because they can go out a little bit further, and they became more adept to swimming. And they slowly, slowly turned. What you're looking at with Pakicetus is this is the first whale. Take a moment to think about that for a second. This is the first whale in recorded history. This will eventually become an orca. This will eventually become a killer, or the same thing, sperm whale. This is first blue whale. These are all the whales you've ever seen. This is the first one. And that's when we're looking at paleontology. How can we show that? How can we prove that this is the first whale? How can we actually take a look at this animal and say, well, that's what he eventually will become? And we're going to talk about all of that. I just wanted to start with something. Now, obviously, in paleontology, there's plenty of animals we're going to look at. Like I said yesterday, the most famous collection of animals is dinosaurs. Dinosaurs are completely misunderstood by people today because most of your guys' education comes from Jurassic Park or as a really young kid, and it's shaped so it could be more easily understood by kids. Since we're adults now, we're going to actually talk about what the evolutionary history of dinosaurs is in this class. We're going to talk about even before that. We're going to do a lot. Online, a lot of the class kind of dictates a lot of geology, a lot of Mr. Urquhart stuff. I really don't want to do that. I want to stick with more a biology aspect of this class. So I might change up a lot with the online class. So please, don't get too far ahead. Obviously, I want to give you guys small snippets at a time on there. But just know that it's not really a regular paleontology class because it has a biology teacher spin to it. Now, for today, tomorrow, we're going to be working on a lab. And since you're not here, it's going to be a little bit harder to do the lab, but we're gonna make our way through it, I promise. So the first couple of days, we're going to look at perspective. I want to start, like I said, very broad, and I want to look at the world. The world has changed a lot over the course of its history. The Earth is about 4.6 to 4.8 billion years old. It didn't take very long for us to get life. The most fossils to date are in Australia, about 4.6 billion years ago. We have our first bacteria cells. in Michigan, there's actually a bunch of fossils. We're actually one of the oldest fossils up at the Black Rocks in Marquette. So maybe you guys went with Mr. Urquhart up there at one point, or you've been to Marquette, where Northern Michigan University is. As you're driving into town, there's these giant cliffs on the left side. Those are the Black Rocks. If you actually dig in those rocks, you can find microscopic fossils, which is kind of cool. So this is what our Earth looks like today. As you can see, it's what you've been seeing on the map for a long time. I do want to point out that as a science teacher, I want you guys to see how big the Pacific Ocean is. Based on the maps we use in class, you guys really don't get a real good concept of how big it actually is. It's enormous. It's about 1/3 of the globe itself. And we go around, you can see China, India, Russia, Saudi Arabia, Africa. Please point out too here that Africa is quite enormous, especially when you compare it to Greenland. Why I bring that up is the maps we use in school make northern places by the poles look a lot bigger, and southern places by the poles look a lot bigger, and places in the middle look smaller. If you actually look at a map in a textbook, Greenland looks like it's almost the same size as Africa. As you can kind of see, not even close. And you can even see Alaska. Alaska looks big in our textbooks. But realistically, it's huge, but it's not nearly as big as what it looks like on a piece of paper. So this is the world. It's a beautiful, beautiful planet. We're very fortunate to have such a nice planet. But this is not what it has always looked like. And this is not always what the life has looked like on planet Earth. If I go all the way back here, I can change it here. I want to go 750 million years ago. This is what planet Earth looked like. And you can see, well, a lot more water. Okay. And you can kind of look around. I'll put the site online so you can play with it at your house. You kind of look around and try to find where Michigan is on these outlines. It's sometimes a little hard. I can't really see it right now, but you can take a look and try to see. I can see Canada here, so I'm assuming Michigan's right here. So it's down here in the southern hemisphere. We can keep getting closer. So sometimes that you guys probably know about, like 260 million years ago, started the dinosaurs. Try to see what the world looked like at that point. There's Michigan right there. I always tell my class 340 million years ago, right here, we were a tropical sea, Michigan was. That's one of the reasons why Detroit is actually one of the biggest salt mines in the history of the world. Underneath Detroit, it's literally all salt. Unfortunately for Detroit and Michigan, salt doesn't really make us much money. Everybody has salt, so it's kind of a waste. But when you guys see Morton salt, most of it's actually dug up in Michigan. And you can get closer and closer, and you can kind of see what the world has changed. We're getting kind of close to what we are now. You know, North America is moving away from Europe. You can still see there's actually an ocean in the middle of our country. You can see South America is not attached yet. There's a bunch of stuff going on. Okay. So what we're going to do today in our lab is not so much play around with the plate tectonics like this and what you guys learned in 9th grade. I want to go through the history of the Earth and when things happen and when things were. You will probably see, let me get this lab attached here. Now, this lab requires 5 meters of adding machine tape. I'm assuming you don't have adding machine tape at your house. That's like the spool of receipt paper that you have at stores and whatnot. That's fine. You can use a couple different things for this lab to make sure that you guys got it done. You guys can, I've had people before use chalk and go outside and go put it on outside. You are going to need a ruler or a meter stick to do this, or a tape measure of some kind. And then whatever kind of like item you put this on. Anyways, going back. So I've seen people do chalk outside. I've seen people use just masking tape, and they just laid out 5 meters of masking tape. 5 meters of masking tape, 5 meters in general, by the way, is roughly about 18, 20 feet-ish. Anyway, so you're going to do that. In class, they're going to use machine tape, and they're going to follow through this lab. So you got to read the directions. I'm not going to read them to you because it'd be a very boring video. You're going to go through it. You're going to add these geological times. These are the ones that we're going to learn about and what animals and plants look like during these times. So we're going to learn about these. So I want you guys to put these on there. And I want you guys also to write down and put marks for these things. You might need to look up these things on a computer and figure out when the first insects were, or when oxygen started to be in the air, or when we had the first birds. Okay. Then you're going to answer the questions, and you're going to show me your lab. So because you're not in person, this becomes a little bit more difficult. So you're going to need to take a picture of anything that you make physically. You're going to need to take multiple pictures. It's not one picture from afar. I have to take pictures of the whole thing and then the snippets of in between so I can actually see what you put down. With the analysis, you guys can just put that into a Google Docs and send it my way. So you have multiple things to turn in on this one. You are going to get 2 days to do this. This is not just a one-day thing. You're going to get today and tomorrow. We're not really going to use Canvas officially until next week, next Tuesday. So this is what we're going to do. So just focus on this. You can turn everything in by email. Just email it to me and I will grade it from there. So if you have any questions, obviously get a hold of me. If you have any concerns, get a hold of me. If you need anything, just get a hold of me. Common theme here. And we'll work through this. Obviously, again, you can always show up at 1 o'clock or 2 o'clock. Sorry, this is a 6 hour, 2 o'clock, and you can kind of hear my spiel again. And then they're going to start working in a lab. So it probably won't be the most exciting class to watch. We're probably going to go outside. So either way, enjoy your day. Enjoy the lab. Let me know if you need any help. Have a great